Okay, so our next step now is to do a pre-order method. So we've seen the in order that displayed for us the content of the binary tree in terms of the nodes based on the keys that are associated to each node, right? So for example, in order, you basically ended up with a sorted output. Right, so notice how we entered the data in this manner, but eventually we ended up with a sorted output when we invoked the in-order method. So now we're going to create what we call a pre-order method, and let's observe what will be the pattern as we output to the screen. So let's go ahead and kind of set it up here. So let's do something like this: system.out.println, even though I haven't created the method yet. And I'm going to call this one PreOrder. And I'm going to make it similar to what we're seeing here. So let me go ahead and do a /n, similar to that one. And let's go back to here, and we're going to do plus our object, br1, dot pre-order. Now this method doesn't exist, so as you can see here, we're going to get a red highlighted syntax here. That's because the method doesn't exist, but eventually that's what we want to do. So we're going to create this method called PreOrder, okay? And we would like to see what the output looks like, and then we'll compare notes to your lecture on that topic, and or part 1 of this series of videos. So let's go ahead and go to the binary tree implementation. You can see here we have the in order already in there. We had the insert method. The technique we used, we had a public method in order, for example, and a private supporting method in order as well that's overloaded. And we call the function from within itself. But the strategy again was, when do we visit the concatenated string that we will eventually output back to the print statement? So let's go ahead and do something very similar, and let's call this one PreOrder. So public, and this will return a string, PreOrder. Okay, and let's open curly brace and close curly brace. Now I have my pre-order here. Let's just make sure that we inspect or must return something. So for now, let me just return an empty string, right? So let's do that, right? So we have pre-order here. So let's go over here, and notice now it's no longer red. That is because that will be the method we will be calling. So let's go back to here. That is not what we want to do. We're going to do exactly what we did with in order. We're going to call a private method called PreOrder, and we will pass root as an argument to it. So that means we're going to have to define a PreOrder method that takes a node as an argument. So this one, instead of returning just simply a string, an empty string in this manner, we're going to call this one PreOrder, except we're going to pass root to it. And notice it will be red because we haven't defined this method yet. And let's go ahead and do it here. And this one will be private. And the reason is we're not going to have direct access to it from main, right, or the application. And this will serve as a service method for the actual public pre-order method. And it's overloaded. So basically, same almost signature at the beginning, pre-order, except for the argument. And that would be a data node, and let's call it node. And for now, let's go ahead and return a blank string. So that way we don't have an error as we compile this program and run it, obviously will not do anything for us yet. So now let's analyze the algorithm needed for pre-order. And this is really where the hard work happens. Well, one thing is, we will return an empty if root was null. Or in other words, if this node here was null, right? So that means it has no payloads, we've never initialized it, we never put anything in there. So we could do something like this. If node is not equal to null, just like we did before, then we're going to do something here. Else, we're going to return this empty string. So let's go ahead and do our else here. And this here will be the statement for that. So now, what are the things that we need to do to make sure that we have a pre-order? Well, we have an output string that we will be returning. So string, let's call it output, right? And we're going to have to populate this string. So in our case, we're going to visit this string right now. So how do we do this? We're going to go ahead and do, if it's not null, then show me what the node is dot toString. What is that going to do? Well, let's go to the data node here. What does a toString do? And let's go ahead to our toString. It basically returns the key and the data, the actual data as a string plus the key as an integer right here. We're going to concatenate to that an empty space to separate the fields. Fantastic. So now a key ingredient of pre-order is we're going to visit the left, then visit the right of this node. And as we do so, we concatenate to our output. So output plus equal, and we're going to do a pre-order, and we're going to take our node dot get left right there, and we're going to do the same thing for concatenating for the output plus equal, and then we're going to do a pre-order, and this would be node dot get left. So this one should be get left. Let's go ahead and do get left here. Get left, and this one will be get right. Node dot get right. Aha. So now at the end, we need to exit this if statement by returning the result, which is our output right there. Okay, well, let's see how that behaves for us. This is how you implement the pre-order algorithm, by the way. So let's go over here. Now we can see that if we run this, we're going to get some sort of a result here. So let's see what happens. And there you have it. So in order, what happened? We got 50 starting at root. Going to the left, we got the 30, right? So right here. And then we went to the left of it, which is 21, right? Then we went back to the right of the key, key that belongs to the root. Let's add some items here. Let's have fun. So let me do a br1 dot insert, and let's add some more items. So let's put a 60 in there. So let's go ahead and do that. So we're going to put a 60, comma, and let's put another item in there. Let's put a plain. Okay, let's see what happens. And let's run it. So as you can see, here it went right, then left.